All right, so now we're going to take a look at how to write the equation for a piecewise function, and we're going to do that starting with word problems first. So a data plan for a smartphone charges 99 cents per day for data usage up to 20 megabytes. So whether you use 1 megabyte or 15 megabytes, all the way up to 20, it's going to cost you 99 cents. It's just a flat fee. And then for each additional megabyte or part of a megabyte, you're going to pay 7 cents per megabyte. We're going to write a function, a piecewise function for the daily cost C of the data plan as a function of the number of megabytes, capital M. All right, so our cost is going to be our dependent variable, and our independent variable is the number of megabytes, capital M. So we're looking for a piecewise function that is C of M is equal to, and we'll need a function and a domain and a function and a domain. Okay, so let's start with this first part here. It's 99 cents up to the first 20. So let's put some markers on our axis here. So we will put a 20 here, a 40, I'll go with 100 and a 200 here. And we know for that first 20 megabytes, it's going to be 99 cents total here. So here's about where that is. And what I like to mark on here, I find it's easiest to construct this equation if I draw a picture to go with it. So if M is 0, because it's just flat fee there, flat function, flat slope. And then I want to put the coordinates of this point on here. So my independent is 20, my dependent is 99, so that point is 20, comma 99. And I can actually write, I know what the equation of this line is because that's a horizontal line. So it's just going to be the 99. And that's going to be for the number of megabytes between 0 and 20. We get to include both of those. Right, and then we need to figure out the second piece of this. So now they're going to start charging 7 cents for each of these megabytes after this. So our graph is going to start going up. And I know that my slope here is 7. And I need to find the equation that goes here. I have my slope, and I have a point that's on this line, so I can use point slope form here. Okay, that was that y minus y1 equals m times x minus x1. And in this case, our variables are that c and the m, so I have c minus the 99 is equal to my slope, which is 7, times x minus, or sorry, not x, m minus 20. And if you write this with x and y and then come up here and fill it in correctly, that's fine too. It's not notationally correct, but as long as you're consistent and the idea is there, you're going to get most, if not all, of the points. All right, and then this says c equals, so I do need to solve this for c equals. I could be super lazy. Mathematicians are known for being lazy. That's why we have all this notation, so we don't have to write very much. So I could just do that. I could just add the 99 to the other side and say, hey, I got my function. That's actually fine. I'm okay if you do that. If you'd rather distribute and simplify, you certainly can. That gives us 7m minus 140 plus 99, which is 7m minus 41. So I'll put my 7m minus 41 here, and that's for any m that's bigger than 20. All right, so there is our piecewise function and our domain and range. So my domain, use the letter D for our domain. We start at 0. We can see that here. And we go until m is bigger than 20. So m can just keep going, 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 gone. So I guess we'll go with infinity here. I don't think you can probably use an infinite number of megabytes in a month. That might be a good challenge. But we'll go with that. That's an acceptable way to put that. And then the range. So the range, we always start at the bottom, work our way up. So the first value we run into is a 99. And then that cost just keeps going up, up, up. So we have 99 through infinity. All right, so there we go. We're going to come back and do another one in the next video.